Hey everyone, this is Mrs. Slauson, one of the Algebra 2 teachers, and I am here to help you get through your 6.2 notes for graphing logs. So I'm not quite sure if this is actually on page 115 where we're starting, but it's pretty close. I've done some editing to this document, and so it might be on 114, 116, I'm not too sure. But we are in 6.2 and we're going to graph logs. And let's just do a little quick reminder. We have our log function. Okay, we have the little part here, the base, and then we have x, which is known as the argument. And if I were to look at its inverse, equivalent version of an exponential function, this would be b to the y power equals x. So that's just something that you already talked about in your previous section. And some things about the log versus the exponent is that the base of the exponent, right there, is the base of the log. And as far as your base goes in a log, that base has to be a positive number, but it also cannot be 1. So if we're thinking of this on a number line, and here's 0, and here's 1, it has to be a positive number, so we're going this way. But the fact that it can't be 1 is going to make an open circle here, and this is our base, all right? And then the other thing is the argument, let me get my highlighter, is also a positive number, okay? All right, we are going to do a little change here because I want you to see a log function in growth form and I want you to see a log function in decay form. So can you join me real quick? We're going to change this graph right here into this. So I'm purposely changing the problem. So on our last chapter, chapter 5, exponential functions, you learned how to graph exponential functions. And as you graph them, you learned about that they have a horizontal asymptote, their domain, and their range. So we are going to start with y equals 2 to the x, and just remind you of how you got these points. And these were our x values that we put in there. And the idea is I can take these x values, put them into here, and get my y answers. So if I just start with the first one, 2 to the 0, anything to a 0 power is 1, 2 to the first power is 2, 2 to the second power is 4, and then the negative exponent just turns them into fractions. So 2 to the negative 1 is 1/2, 2 to the negative second is 1/4. And what we had talked about in the last chapter is we start with 1, because this is technically 1 times 2 to the x. So remember that number is what we would start with. And then this 2 here says I can start to multiply by 2 this way. And then going the other way, I can divide by 2. So just a little quick reminder. And that's where we get these points. So here's 0, 1. Here's 1, 2. Here's 2, 4. Even though it didn't make it on there, here's 3, 8. And then here are those fraction ones. And then we get our exponential shape of growth. And in this, we have a horizontal asymptote. Let's get a different color. Right there, and this horizontal asymptote was y equals 0. And then we could do our domain and range, so we'd have this arrow, which is going right for infinity, up for infinity, and then we have this arrow over here, which gets to keep going left. It's not being stopped, but it is getting stopped going down by this y value, so I can fill in the y value of 0. And you learned that, let me get a different color on my highlighter. So we have a y-intercept of 1, 0. I'm sorry, not 1, 0, 0, 1. It has a horizontal asymptote of y equals 0. So again, that's this. Our domain is our small x to our big X. And what didn't make it on here for some reason was our range. And we have a small y of 0 and a big Y of infinity. So 0, infinity. And over here we have 3 to the x, and so we could go about getting our points the same way as well. Let's take a look at what happens now that we're going to start graphing log functions. So the nice thing about log functions is if you can graph an exponential function, you can graph a log function, because logs or log functions are the inverse of exponential functions. Okay, so one thing we learned about in first semester is, in inverse, we start to switch everything. So what's going to start to switch is this point right here of 0, 1 is going to switch to 1, 0. Instead of a horizontal asymptote, we're going to have a vertical asymptote, and now it's going to be x equals 0 instead of y equals 0. And then our domains are going to become the ranges, and the range is going to become the domain. They're just going to switch. And let's show you how you get that. So we're going to start with our first log function, log base 2 of x. And since we're not that comfortable with y's, we're going to use our knowledge of exponential functions to graph log functions. And we're going to do that, I'm going to move this up, by taking our exponential points. So I'm just going to recopy what's up here. And this is for y equals 2 to the x. And since exponential functions and log functions are inverses of each other, one thing that we talked about when we first discussed inverse functions in semester 1 is that everything switches. So what's going to happen is the x and the y values of my exponential function will switch roles. So what will happen is, let me get my highlighter, is these y values are going to become the x values, and these x values are going to become the y values. All right, so it's going to become, here, let's write these down then. So this is what we're going to be graphing. So let's go ahead and get some of these on here. So here is 1, 0. Here is 2, 1. Here is 4, 2. So we're starting to get our points. Here's 1/2 negative 1, and here's 1/4 negative 2. And that's about it. That's kind of a rough point to graph. And now what I'll do is I'll get my shape. We're about to have logarithmic growth, so we should be seeing it grow from left to right. And instead of a horizontal asymptote, we are going to have a vertical asymptote. So everything's going to become the opposite. And then I'm going to connect my points, and we're going to get this shape here. And then what will happen is the arrow on the right is going to the right, not stopping. It's going up, not stopping. But the arrow on the left side is going to the left, but it will be stopped now. And it's going to be stopped by our new vertical asymptote, which has an equation of x equals 0, because every point on this blue asymptote has an x value of 0. So as it tries to go left, it's going to get stopped by the x value of 0, but it can keep going down and be negative infinity. So what I want to start to do is figure out these shapes. We're going to make a little table, and this is going to be my growth column. And what I want you to see is that growth has a lowercase r, and that's basically kind of the shape that we made here, was a lowercase r. So growth in a log looks like this. So now what I want to do is check out what decay looks like. So this time I'm going to get started with my vertical asymptote. It's still going to be here. Okay. It's still going to be at x equals 0. And now what we're going to do is we are going to get the points for our log function. So I'm going to move over here, and to do that I'm going to use my knowledge of exponential functions. And to show you this, here's a little trick of how you will start to graph these. Remember, the base of a log is the base of the exponent. So if the base of the log is 1/3, that will be the base of my exponential version, and I will just take 1/3 to the x power. So look at this highlighting again, 1/3 to the x power. And I'm going to go ahead and make my table of -2, -1, 0, 1, and 2. And I'm going to start with 0 because anything to a 0 power is 1. 1/3 to the first power is just 1/3. So 1/3 to the second power is 1/3 times 1/3, which gives us 1/9. And then basically, if I'm dividing by 3 this way, I'll just be multiplying by 3 this way. So we'll get our 3 and 9 here. So remember, that's the exponential function. And now to get the log function, so the points for this, my x's, again, will become the y's, and the y's will become the x's. So inverses, everything switches. X becomes y, y becomes x. So here goes, switching these around. Sorry, not the best writing. And then here are my x's. And we're just doing this so we can see a log shape. So let's go ahead and get these graphed. 9, -2 is going to be just barely on that graph. Here's 9, -2. Here's 3, -1. Here's 1, 0. And then my 1/3, over a third up 1, maybe there, and there's my 1/9 up 2. So when I graph this, this is the shape of decay. So let's go ahead and fill that table in. Decay still looks like decay. In an exponential function, this is how it looked. It went down from left to right, and that's what's still going to happen. I don't have a trick to remember that one, like the lowercase r, here, but decay still looks like decay, whether it's exponential or a log. Now, as I do my arrows, the arrow over here on the right is going to the right, but now it's going down. And the arrow over here on the left, it's going to the left, but it does get stopped by this x value wall of 0, and then it keeps going up and nothing stops it. So when I do my domain here, I'll be going from, let's see, where is it? Let me squish this in here. If you want to write this down, my domain is going to be small x to big X. So just showing you, I'm going to use a pink highlighter here. Small x to big X. And then my range, let's switch to a light gray, will be small y to big Y. So we're still holding into this. It doesn't matter if it's decay or growth. All right, before we get to the next part, let's just talk that things can flip. And we're going to let this line here, it always flips over the x-axis. So imagine that this is the x-axis and you want to do a flip. Well, decay then is going to look like this. So this is decay but flipped. And then this is growth flipped. All right, so you're really going to have to know your shape again because you aren't going to get a lot of points here. So growth, decay, but in logs. So for Mrs. Hampton's group, I'm going to skip this part on the top of the next page and go to here. So let's just remind ourselves of the jobs. There is sometimes a negative here. The negative reminds you you will have your flip. A is your stretch. Oop, not spelling that right. Stretch or compress. And your H, remember we always do the opposite. And that will tell us to move things left or right. And then K, we will leave it as it is, and that will tell us to move things up or down. So before we get started, the one I want to change is the very last one. I do not want to keep this problem. I want to have a log, and I want to have 1/2 x plus 3. And then the other thing I want to do, just so you can start to see everything, is in front of the first one, I'd like to add let's add a 3 to it, like this. So we're just going to do some quick modifications to this so you can get the full sense of graphing. So goodbye to this version and goodbye to this version. All right, so we are going to graph logs. And to graph logs, we are going to use our knowledge of the exponential version to graph the logs. So how do you get this whole thing started? Well, what we're going to use is the exponential version. And remember, the base of your log is going to be the base of the exponent. So I want you to almost look at this as 2 to the x power. And we're going to make a table for this so that we can find our y values. And again, we always choose these for our x values. And we'll start with 0. So anything to a 0 power is 1. 2 to the first is 2. 2 to the second is 4. And then 2 to the -1 and -2 just moves those results into fractions. Now that's the exponential version. To get the log version then, again, I'm leaving all the other stuff out. To get the log basic version, I will switch the x's and the y's around. So these y's of 1/4, 1/2, etc. will become the x's. And the x values of -2, -1, 0, 1, and 2 will become the y's. And that is how you get the whole thing going. Because again, we're not as great with exponential functions, or we're better with exponential functions than we are with log functions. So no longer needed. This table helped me get the new table. So let's start to talk about these numbers that are in here. So we do have a stretch. I'm just going to abbreviate that as stretch. And then that's our a value. So a being 3, we're going to have a stretch. Well, I'll write it out. And then we're going to have an h value of 3, which means everything's going to go right 3. Because it's in parentheses, h is always in parentheses. All right, let's start with the wall. And I'll be doing some erasing here. Again, my wall typically goes like this. One trick that I remember that logs have a vertical asymptote is that log has an L, like an upside down line. So that's why I always remember that. And this wall is affected by my stretch, compress, flip, left, right stuff. This wall is affected by going right 3. So this is going to be my new location of my vertical asymptote at x equals 3, because every x coordinate on there is 3. And what I'm going to do is now go to these points. I'm going to get them graphed. In just a moment, we still have to do a little bit more work, and we're going to be moving them right 3. So when you get your table, we always start with our stretch, our compress, and our flip. And this stretch or compress flip always affects the y values. So I will be taking all of these y values and multiplying them by 3, because that's what happens with the stretch, a compress, or a flip. So here are their new values, just multiplying by 3. 0 is still 0. And since I have new y values, I really don't need these old y values. So what I always like to do, if you've ever seen my past videos, is I like to cross those off. And I'm going to start graphing my nicer and easier points 4, 6, 2, 3, 1, 0. So right now I am at 4, 1, 2, 3, 4, 5. Oh, where am I? 1, 2, 3, 4, 5, 6. This is 4, 6. It is not going to stay there. It is going to be moving right 3, so it goes to here. And then here's 2, 3, over 2, up 3, and it won't stay here. Whoops, I meant to do that in green, just a sec. So my wall disappeared. Where are we? So here's 2, 3, which won't stay there, right? It's going to move over 3. 1, 2, 3, right there. And then 1, 0, which is normally here, that's also going to go right 3 and 1, 2, 3. And I will not worry about the fractions. I guess if I really want to do them, I could, but this is growth, and growth looks like a lowercase r. All right, and I just realized this point was a little bit off, so sorry about that. My 2, 3 wasn't correct. Here's my wall. And here is 2, 3. I miscounted, and I'm going to move that right 3. 1, 2, 3, like that. So with those points, I'm ready to draw my shape. Because my base is bigger than 1, what we learned in last chapter, it's worth 2, is that will tell me my shape. And 2, being bigger than 1, is growth. So just going back up here, this is going to be this top left side, this growth, like this, that's the shape. I know that's my shape. So I'm now going to draw this. Here we go. We're going to do our arrows. So this arrow is right, this one right here, and up. Nothing stopping it. And this arrow is going left, but it will be stopped by my X value wall of 3. And then it's going down, nothing stopping it. So when I'm ready to do domain and range, I'm going to have my small x to my big X. And then I'm going to have my small y to my big Y. All right, let's try the next one. So our next one, I'm going to make my table. So I'm going to let my knowledge of exponents help me. And so I'm going to look at the base of my log. And that will be the base of the exponent. And it's going to be 3 to the x power. And so again, for exponential functions, these are our x values. And anything to a 0 power is 1. 3 to the first power is 3. 3 to the second power is 9. And then here come their fraction versions like that. And now, because I'm going to graph the log version, I'll get a different color going here. So again, the log version is this. This is my parent function. So my x's become my y's, and my y's become my x's. So I'm just going to switch those around. And we're doing this again because we are not great with log functions. So we're using our exponential points help us find our log points. And then I don't need these points anymore. I've got my log points. So let's talk about our transformations before we get graphing. We do have a flip this time. We don't want to forget about that. And then this is my h. H is -4, which means we will be going left 4. And let's go ahead and start working. So whenever there's a stretch, a compress, or flip, that flip, stretch, or compress will always change your y values. We learned that in first semester. So all these y's are going to become opposite of what they currently are. Always change the y's, never the x's. So -2 becomes 2, -1 is 1, 0 is still 0, but now we're going to have -1 and -2. And then I don't need these old y values because I've got new y values. All right, let's get these on here. Then we're going to think about the shape, and we're going to get them graphed. So first, let's start with our wall. Again, our wall is normally here, but this wall is now going to move left 4. 1, 2, 3, 4, and end up right here, which gives us an x value of -4. That is your vertical asymptote equation. And so now I'm going to start with 9, 2, which this graph paper, 1, 2, 3, 4, 5, 6, 7, is at 8 all the way over. So 9, -2 is about here. But it's not going to stay there. It is now going to move left 4. So I'm going to put my new color in blue. So 1, 2, 3, 4. This is where it is now. This point's gone. And then 3, -1 is now going to go left 4 and end up right here. And then 1, 0 is going to go left 4. And then that's all the points I'm going to put on there. I don't like to put the fractions. So if Mrs. Hampton had you do that, well, great. I'm going to erase these green ones that I don't need. And now I want to think about the shape. So this is growth, but it's growth flipped. So let's come back up here and remember that. This is growth flipped right here. Whoa. Oh, I don't know how to fix that. I keep having my eraser going. Let me fix this real quick. All right. So growth flipped. Sorry about that. So this shape right here is what I'm going for. And that's what I'll do. Now when I'm ready to do my arrows, this arrow is going right and down. And this arrow is going to the left, but it will be stopped by a vertical asymptote of -4. But it will keep going up. So when I do my domain, small x, big X, small x, big X. And when I do my y's, small y, big Y, and, whoops, sorry guys, this is really tight writing, -infinity to infinity. All right, last one. Let's see if we can do a shortcut now and not make 2 tables. So remember, I did switch the problem on you. I want to try to make one graph, and that's it. And I'm going to remember that I am switching x and y around, and I'm going to let the base 1/2 to the x power be my guide as I make this table. So what I did in the first two problems is I made the exponential version and then I switched them around. I'm going to go ahead and just do the switching around. So there we go. And then I'm going to put these numbers here into this so I can get the next column. I hope this is making sense. So anything to a 0 power is itself. 1/2 to the first power, sorry, anything to a 0 power is 1. 1/2 to the first power is itself. 1/2 to the second power is 1/2 times 1/2, which is 1/4. And then I'm going to flip those numbers around because of the negative exponents. And I have already, without making two tables, done this. That is that. I hope this makes sense. So I tried to save some time. You don't have to do that. Let's talk about our transformations. We do have one extra number. This number is not in parentheses, where we had numbers in parentheses on the first two examples. So this will be an up 3. So let's take our vertical asymptote, and it will stay here. It's not moving left or right at x equals 0. And I'm going to take my points, like 1, 0, and 2, -1, and 4, -2. And I'm going to move all of these up 3. So let's go ahead and move these all up 3, up 3, up 3, up 3. And then this is decay. The reason why I note decay is because my base is less than 1, and that's something you learned about in the last chapter. So decay, going back up here, decay looks like decay looks like decay. So it's going to be this shape right here. So just knowing a few points, I'm going to get rid of these original ones. And I'm now going to graph my decay shape. And this arrow is going right and down. And this arrow is going left, but it's going to be stopped by my vertical asymptote of 0 and going up. And now when we do end behavior, right, as it goes to infinity, I can put -infinity. And then it's actually, the other one is not going to infinity. It's going to 0 from the right side. That's what this plus means. And I will get infinity. So a little different there. All right, let's wrap this up. You guys have been very patient. Let's get this page done. And we are going to remind ourselves of our special logs. And so, well, we didn't have one here. But remember, if you just see a regular log like this, it has an understood base of 10. And if you see ln, it has a base of e, and e is about 3. It's about 2.7-ish. Okay? And when we graphed our exponential functions, we only used 1 point. All right, so we will be sketching this graph first. Let's talk about our transformations. We do have an h value of -1, so everything's going to go left 1. And there's an invisible e here. So if this were my exponential function, e to the x, then anything, including e, to a 0 power is 1. So when I do the log version of it, I will just switch those two numbers around. But then I'm going to have to know the shape. So this is growth because the base is e. So with the base of e, I got to remember my shapes. And growth, remember the word growth, has a lowercase r, and this is what our shape is going to look like, something like this. So let's go for our wall. Remember, we are graphing this, not this. We have our vertical asymptote, which is going to move over 1, left 1. So here's x equals -1. And then my point of 1, 0 won't stay there. It's going to move left 1. So if it moves left 1 and I'm at 1, 0, it's just going to end up at 0, 0. So left 1 means my x values goes down by 1, so it ends up at 0. And then it doesn't go up or down, so it just ends up at 0, 0. And then I can draw my shape through my 1 point. If we do these arrows now, this arrow is going right and up, and this arrow is going left, but it's going to be stopped by my x value vertical asymptote of -1, and it's going down. And then we can do the domain, which is small x to big X. And then we can do our range of small y to big Y. Or we could just write the fun R. All right, let's talk about this one. So on this one, let's actually change it. I know I keep changing things. So let's do this. Let's get the other one in there. So a reminder, we are going to have a flip, and everything's going to be moving right too. And I normally want to make my table, and we would be using our exponential version. So when you don't see the base, remember there's a 10, so I would do 10 to the x power. So if I were filling these all out, remember anything to a 0 power is 1, 10 to the first is 10, 10 to the second is 100, and then I would get their fraction versions here. And probably the only two that are going to make it on my graph are these two. So when I'm ready to find the log version of this invisible base, I will take my y's, they become my x's, and my x's will become my y's. So I'm going to go to 1, 0, about there, and let's say 10, 1 is here. And I normally have a wall of here, but now everything's going to move right too. So when 10, 1 moves right 2, I'm going to add 2 to my x's, and it becomes 12, 1. And when it moves right 2, I'll add that, and that becomes 3, 0. So let's say here's 3, 0 now, and here's 12, 1. And then growth. Growth, oops, sorry folks, I already messed up. Hold on, let me fix this. Oop, messed up. Back up. So where did I mess up? Here we go. Okay. Backing up. Our wall is normally here, and it's going to move right 2. So it's now at x equals 2. All right, what did I forget? I forgot the flip. Sorry about that. So whenever you have a flip, a stretch, or compress, that changes your y values. And 0 is still 0, but 1 is now -1, and I've got some new y's, so I cross out my old y's. All right, so I am supposed to be at 1, 0. It is going to move to the right, 2, so that still happens, add 2. So 1, 0 moves right 2, and it ends up at 3, 0. And then 10, when it moves right 2, I'll still add 2, becomes 12, but it should have been a -1 here. So, I don't know, maybe like here. And now I do have to know the shape because I have very few points. This is growth, but it's growth flipped. So growth flipped right here. This is our shape that we're going for. So that's what I'm going to do. Growth flipped. All right, let's get our arrows done. So this arrow is going right and down, and this arrow is going left, but it's going to be stopped by my x vertical asymptote of 2, but then it's going up. And now my domain is going to be small x to big X, and my range is going to be small y to big Y. All right, how can you do the domain without sketching the graph? Well, if you remember, this argument has to be positive. It has to be bigger than 0. So if I just want to find the domain, I can set the argument against greater than 0 and now just solve for x. So I'm going to add the 2x over, and then I'm going to divide by 2. And I always like it when the variable's on the left side, so I'm just going to switch it around. And so here is my domain. My domain has to be bigger than a half and then it can't include 1/2. So if I were writing this, this is as an inequality, but as interval notation, it would go 1/2 to infinity with parentheses. All right, that it is. And that's it. And again, why do log functions have domain restrictions? They have domain restrictions because the argument has to be greater than 0. Those are your notes. So you'll get started on the practice here, and hopefully you have no issues. Remember, Mrs. Hampton does post the video, or sorry, the answer key for you in your weekly folder, okay?